We are group number 23 presenting NYC taxi trip data analysis. With the US ride-sharing market projected to reach $106 billion this year, analyzing ride-sharing becomes ever more important. Currently, there's a gap. Both users and drivers lack access to ride-sharing analysis, hindering their experiences. Passengers, drivers, and governmental agencies can tap into these analyses. We chose New York City for a reason. New York City's unique taxi industry plays a crucial role in the city's transportation. It is a backbone for New York City. Coming to background and motivation, our core motivation behind this work is to leverage granular NYC taxi dataset to uncover actionable findings that improve taxi services in the city for all stakeholders. Those stakeholders particularly being drivers, passengers, and governmental agencies. For passengers, analyzing taxi availability across different areas could empower trip planning, making sure that they can use the opportunities of supply and demand to get cheaper rides. For drivers, it means mapping pickup and drop off locations to optimize routing and increase their earnings and profitability. And finally, for governmental agencies, it means better urban planning and infrastructure improvements. We are well aware that urbanization increases transportation demand, and transportation demand contributes to carbon emissions. That is why we are predicting carbon emissions. Predicting carbon emissions allows us to make better urban planning and infrastructure improvements and make sure we can build sustainable solutions and actions. Next, Shivram will talk about the analysis and findings of the study.
This analysis includes data from 2021 to 2023. We did some preliminary analysis and saw that the yearly trips decreased significantly from 2022 to 2023. This can be due to the fact of the increase in the number of remote jobs in the recent years. We also performed analysis on tip amount and distance. And we noticed that as expected, the tip amount was good on weekends. And we also noticed that Wednesdays have the worst tip amount percentage. We also performed busiest location analysis. And as expected, Manhattan areas and airports like LaGuardia and JFK actually are the hotspot regions. But one interesting finding in this is that the total number of pickups in these airports is actually greater than the total number of dropouts. This can be attributed to the fact that more people are coming to New York City because of the increased opportunities and better quality of life. So this is just a conjecture. Also, we performed a cost model analysis for the taxi services. So we assume that the trips with the zero passenger count are actually the trips where the driver could not find a booking, and the fair amount involved in this is the actual loss or cost to the taxi services. We see that from November to December, or especially in these holiday seasons, the total cost is actually very high. And if they have access to these models, and hotspot regions, they could have made a better decision and then put more taxis in these hotspot regions. My contribution involves working in the system architecture for client server model and also developing APIs for time series analysis. I also worked on tip and distance analysis and the spatial aspects of the project like hotspot inspection and spatial visualization and also spatial joins. I also worked and developed the cost model estimation for the taxi services. Now Surya will continue with our next analysis.
Greetings, my name is Surya Chandrasekhar Kumar, and I'm here to talk about carbon emissions and how we took a feature engineering based approach along with the power of distributed big data processing for the New York taxi trip dataset to estimate the carbon emissions. What's the background and motivation for this study? Increased urbanization increases the transportation demand, which in turn increases the carbon emissions. And the New York's unique taxi industry plays a crucial role in the city's transportation, which suggests that there should be better environmental awareness in the city along with policies, which then calls for more sustainable solutions. I performed exploratory analysis using Beast. I suggested the adoption of Parquet files for a more efficient analytical processing instead of the traditional DB. We earlier were using PostgreSDB for analytical queries. I performed data pre-processing. The data by itself was not very clean. We had to suggest a schema. We had to filter out data. We had to clean up the data, handle a lot of empty values and stuff. So I helped with the data pre-processing. I performed the feature engineering, which is essentially carbon emissions. So carbon emissions was a new feature that was engineered as a measure of trip distance and trip duration, as per the estimates provided by the US Environmental Protection Agency. On this newly engineered feature, we also performed a temporal analysis using Spark, and we performed spatial analysis using Beast and Spark. Improvements over the initial approach. Does anyone of you know why pandas are slow and clumsy? Because they run on driver only. Anyways, it's a joke. Pandas is a library that we use for analysis, and they're generally done sequentially. They cannot run in a distributed setting. So we adopted a big data approach that analyzes huge data sets using the Spark's distributed nature and Beast. We migrated from a database-driven approach to Parquet for analytical processing, as I mentioned earlier. So how did we achieve the temporal analysis using Spark? So we loaded the data from Parquet files, stored it into data frames, and then we performed certain transformation, which included filter. Filter was essentially to filter out certain data. As I mentioned earlier, this data was not very clean. We had to process it. Also, there was one complex challenge that we had because since we loaded it from Parquet into data frame, it inferred the schema by itself. which kind of complicated a lot of things. So we had to provide the schema as well. We added columns. These columns are essentially the day of the month of the year, and the hour of the day, which were then used for the group by and aggregate. And then during the write action, all of this was written into a CSV file and then stored as a result. What this essentially did was it tried to predict the carbon emissions for various period intervals, as I mentioned. Exploratory analysis using Beast. So we used Beast and Spark to find the most frequent routes as line strings. We had two data sets, one with the spatial data, which is the S3 shapefile, and the other is the taxi trip data set. We performed a join using the foreign key, which was the location ID. We calculated the centroid of these polygons from the shapefile, which was the pickup zone and the drop zone. And we generated a line string between these two centroids. So using Spark, we aggregated the results. We essentially added one for each row, and we reduced by the key, which was unique in nature, the unique line string that we have, which then led us to a surprising result. Only a few top routes were contributing to the result in a major dominant factor, while a huge subset of the data weren't really contributing much. We then generated a WKT, a well-known text file, and saved it so that we can visualize it in geographical information systems. How this may be helpful, this helps us understand, the file itself will help us understand and do better urban planning. We can focus on where to put the green zones along the most busiest zones. We can focus on which areas we need to start up if at all we are moving to electric fleet of taxis, which routes generally would require more electric taxis or hybrid vehicles, better public transportation, and better bike lane planning. All of this leads us to perform spatial join over various publicly available datasets that contain the related data that I mentioned. And of course, this is a study that we would like to do in future. Over to Bhavya, who's going to talk about regression models and predicting the fare price and the tip amount.
Hi, I'm Bhavya Gada. I will start with explaining the regression analysis performed in our project. We performed this analysis to make predictions and infer causal relationships between features. One of the analysis we did was to predict the fare amount given the total trip distance, and another was to predict the tip amount given the total fare of the trip. This prediction model can be a useful tool for the drivers to estimate their earnings. One of the causal relationships which can be inferred from the analysis is that as the trip distance increases, the fare also increases, and a similar trend can be found for the tip amount, which increases as the fare increases. This model was evaluated using mean squared error, which is a widely accepted method for regression analysis. One of the challenges faced was the existence of outliers, as you can see in the image here, and this required careful handling of the data along with hyperparameter tuning and model optimization techniques. Another analysis performed was spatial visualization of aggregated data insights for each of the taxi zones in New York City based on specific filters. As you can see in the demo here, you can see pickups and drop-offs for each zone based on the time of day, the day of week for a specific year, along with average cost, average trip distance, and average passenger count. These were some of my contributions. I performed the regression analysis using PyTorch along with hyperparameter tuning and model optimizations. I helped with web UI components and some of the visualizations built using React, and the spatial analysis we just saw was performed using OpenLayers library. Now Bijit will continue with more spatial visualizations along with related work and conclude the presentation.
Hi, I'm Abhijit, and I'm going to talk about the point of interest analysis along with the related works and the conclusion. So for the point of interest analysis, we perform two different types of analyses. And for the first one, we use the general points of interest like parks, restaurants, etc. With point data, which was converted to polygons at runtime while doing the analysis. And then we perform the spatial join with the pickups and drop-offs. So the visualization is here. And as you can see, more pickups happen near points of interest, which was an interesting result that we obtained. The next one, we use a specific data set just for the New York City subway stations and converted this into rectangles using QGIS, which was more efficient than doing it at runtime. And then we performed a spatial join with all the taxi trip data to analyze the number of taxi rides which are happening to go to the subway station. So these are all the taxi rides, and this is after performing the spatial join, which also helps us answer some interesting questions. So for the related work, 4 of the related work also use visual analysis techniques to analyze the latent patterns in the NYC taxi trip data. All these links are given below. For 2 of these, they also use specifically heat map analysis, and these ones use the exploratory data analysis to discover different patterns and trends. Where the third one actually uses data from Chicago instead of New York. These two also use regression and estimation for predicting the fare amounts and tips, just like we did, and we obtain similar results as them, which validates our results. So these are my contributions here to perform the spatial analysis for points of interest, as I mentioned earlier, perform the no passenger cost analysis, which will be mentioned in the reports, and the insights that were generated were consolidated into outcomes for the evaluation section. So in conclusion, all these insights that we developed for usage, tip amount analysis, etc., can be used to increase the efficiency. Manhattan and the 2 nearby airports were emerged as hotspots, and points of interest analysis indicated the things that I mentioned earlier. And all these various types of insights can help make the taxi services more efficient. Thank you.